The maker community and hobbyists play a pivotal role in fostering innovation and collaboration across diverse domains, including maritime environments. Hobbyist maritime projects span a diverse spectrum, from autonomous underwater vehicles revolutionizing ocean exploration to collaborative mapping initiatives enhancing navigational precision. Projects like ArduPilot expand beyond aviation and showcase the versatility of individual and maker community contributions in shaping the future of maritime technology. The transparency inherent in the open source can enhance software quality and cultivate a global network of contributors. Maritime is not an easy domain to work in, however. Challenging testing requirements, complex logistics make this difficult for individuals. Nonetheless, a flurry of innovation continues in garages and basements by motivated individuals. Welcome back to the IQT podcast. I'm your host, Vishal Sandesara, and on today's episode, we continue our three-part exploration into the maritime domain. On today's episode, we will discuss maritime innovation in the open source and maker community and how these projects and efforts are shaping our understanding of the oceanic and undersea world. Joining me on today's episode is Mike Chadwick, good friend and colleague from IQT Labs. Welcome, Mike.
Thanks, Vishal.
Thanks for being here. Mike Chadwick is the Deputy Director of IQT Labs, responsible for Edge Technologies focus area. In this role, Mike oversees high-level decisions across multiple projects applying machine learning to technology demonstrators. And allow me to reintroduce myself, Vishal Sandesara, host of the IQT podcast, also a member of the IQT Labs team. Happy to be here and happy to have this conversation with you today, Mike.
Yeah, likewise.
So let's talk a little bit about something our listeners might not know so much about if they're recent listeners, and that's IQT Labs. We sit within IQT. You and I have been part of the labs now for a number of years. What are we doing at IQT Labs, and why should people care?
Yeah, so high level, IQT Labs is an applied research and prototyping group within IQT. So IQT Labs has existed since around 2011. It's taken a number of different looks and feels over the years. Originally, it was focused on sort of big data problems back in 2011. We evolve over time based on sort of what are the needs of our customer base and what are the challenges in technology adoption today. So right now, we're really focused in two thematic areas. One we sort of notionally call edge tech, which is really AI decision-making out at the edge. That's sort of resource-constrained environments, places without internet connectivity, maybe limited compute capability. The other side is AI assurance, so looking at as you adopt more AI into production settings in industry, academia, the government, how do you know that your AI systems are working? How do you know what to do when they break? Those kind of things. That's sort of holistically what Labs works on. We focus on doing development projects. So we build prototypes and demonstrators to sort of showcase how this technology works, where are the places that are solved, where are there places that really need sort of venture-backed investment, and where do you need to go really to sort of like a big system integrator to solve certain problems.
That's great. I'd like to sort of draw the line and the distinction with IQT Labs as following. You've got IQT making investments, looking at the tech landscape and commercializable or commercialized technology, and we've got IQT Labs where we're looking at things that aren't quite yet commercialized, perhaps don't have as much of a market opportunity, but are still important problems to solve for our national security concerns.
Yeah, and that's not necessarily to say that the technology is 6-7 years away. There may be technology that's ready now. It just doesn't have quite the right market conditions for a business to start up around it. So that's those areas we look at as well, and I think that's particularly pertinent to this conversation about maritime environment.
You know, I think something else that's important about IQT Labs is, today we're talking about the maker/hobbyist community. We're talking about open source, and IQT Labs is, in my opinion, a member of this community, and also has lent to the maritime domain through a variety of our own projects, both sort of starting original projects and contributing to those that exist already. Why is it that it's important for IQT Labs to be a part of the maritime domain, and sort of what are your thoughts on our continued involvement in the domain?
Yeah, I think when we sort of decided to get into this space, we thought about this a lot back in 2021 about where should we go. It was the middle of COVID. We were trying to make some assessments of like where's there going to be the next pop-up of open source innovation. And we decided that maritime, the conditions were just right. It seemed like you mentioned ArduPilot in the intro here. That was just adapting from being really focused on drones and fixed-wing sort of aircraft. Sort of ArduSub had just come out, which is sort of the underwater version of ArduPilot. ArduBoat had been around for a few years. So a lot of these technologies were starting to sort of make their way into the maritime space. And there were a number of open source projects that were starting up in that space around buoys and unmanned surface vessels and even underwater vessels. So that's sort of when we started thinking about this. The why for us is really our customer base and the U.S. government really cares a lot about the maritime space. I mean, it represents 70+% of the planet. A lot of our commercial commerce happens on the seas. It's just a really important area for the USG to sort of take care of and have good technology to put to bear. So that was sort of some of the thesis behind why we started to get into it. It seemed like the maker conditions were right. It's a place that our customers care deeply about. It's also a place that society really cares about, spanning the gamut from resource exploration for commercial enterprises all the way to conservation efforts with sort of fishery maintenance and sort of protecting endangered species. There's sort of a big maritime component to that. So we felt that it was a place to really start focusing in on.
In your opinion, as we look across the open source and maker community as a whole, what do you think about the opportunity that individuals and small groups, as opposed to, say, larger commercial entities or well-funded or well-backed commercial entities, what is your opinion of the impact that can be made in this domain by players of that caliber?
I think this is a particularly interesting space, in my opinion, because a lot of the companies that are out there and the podcast that precedes this one, I was really focused on sort of that technology and innovation and investment space. There's a lot of very large companies that are focusing in this area. There's a lot of very niche companies that are focusing in this area. But the open source technology has gotten to a point where individuals can actually access it and build really interesting things without a lot of money and without a lot of time. And so I think that's just sort of where I think this is really interesting. It's a pretty accessible landscape from a technology perspective. I can build an autonomous boat for $400 or $500 with the right parts and sort of put it together. So I'd say, to answer your exact question, it's pretty accessible to the individual. It's very accessible to small groups of people if they want to start dabbling in this space and getting involved. So.
You mentioned universities working on boats, and that's of particular interest because that's actually something you are actively engaged in at the labs. And we'll talk about that a little bit more a little later in this podcast. So just getting back to some of the interest in the hobbyist space, let's focus on sort of all the different technologies that we have encountered or that we have either helped develop or are part of developing currently. Certain things come to mind. I think autonomous systems come to mind. In general, solar electric systems. We talked about ArduPilot. Where is it, in what technology vertical do you think it is that we are most focused in right now as IQT Labs? And where do you think that we'll shift our focus to, if at all, as sort of time goes on, as we spend more resources and time in the domain?
Yeah, I think I'm going to answer this twice, one from a couple years ago and one for sort of the next couple of years.
That's great.
So a couple years ago, the conditions seemed ripe because there were a couple of projects that were starting to build out examples of how to build an unmanned surface boat, an ROV. And it was really predicated on the autopilot technology just being really cheap and available and migrating from drone-based. So a lot of the investment made in sort of quadcopters and aircraft was making its way into this community as well. So it really reduced the barrier to entry for individuals, hobbyists, universities, those kind of things to take advantage of this tech. At the same time, AI was really becoming much more mature in a field setting. So computer vision was pretty usable at that point. AI on audio, sort of spectrogram-based approaches were increasingly accessible. And so that's a large part of the drive, from my opinion, of what is catalyzing a lot of the motion right now in the open source space. And we see this with competitions that are out there, like I think it's called MicroTransat, which is sort of a transatlantic autonomous boat regatta that happens annually. People can universities, individuals can go in and just send an autonomous boat across the ocean. And they've had a couple of successes. I'm not sure what the success rate of that is, but it is approachable from a technology perspective. Moving forward, I think the big change that's going to happen is satellite connectivity is going to change this world a lot. Looking at what people are doing with Starlink, which is really the biggest change in SATCOM because there's no cell networks in the ocean. Comms is one of the biggest challenges. How do you control an autonomous boat that's out in the middle of the Atlantic? It's really hard. People were controlling them with sort of limited SATCOM without being able to tell it a lot of what it was supposed to do, and pretty much without being able to take video or audio or any of the data off of the ship itself. I think that's going to change a lot in the next couple of years as a lot of these satellite constellations come online. Starlink is already usable. There's more constellations that are being built out. So I think that moving forward, that's going to be the big change because it's not that expensive. It's approachable by an individual who's motivated to do this from a cost perspective.
That's right. I recall on a few of your projects, you and the team discussing the different sort of options you'll have when it comes to doing data backhaul or having connectivity to a particular prototype that might be floating or somewhat submerged. I know that we've leveraged a lot of, in some cases, portfolio technology, IQT portfolio technology. We've also sort of looked at other options that exist like Starlink. You mentioned drones, and I know we're talking about maritime today, but I think we'd be remiss if we didn't discuss sort of some of the spill out or the contagion effect that open source or maker drone contributions have had in the maritime domain. And as we sort of juxtapose the Russia-Ukraine conflict and sort of the proliferation of the usage of drones there and the open source and sort of maker contributions that have been lent in that space, a lot of that sort of adds fuel to the fire for I think some of the stuff that we're seeing in the maritime domain. I'd love your thoughts on how versatile, I guess, open source work can be and how it can be leveraged across different domains. And one last point, just to add as background, I know that you and your team spend a lot of time thinking about this when you're prototyping. You've got projects like Skyscan, projects like AI Sonobuoy, which we'll talk about later, that leverage a lot of the same sort of hardware backbone, and even in some cases, some of the software backbone is somewhat analogous. And really, the domain difference is just sort of a minor change that you might make. Certainly changes the aesthetic and the look and feel of the thing you're making, but I think that you found that there's a lot of versatility in what you've made and a lot of reusability in different domains. I'd love your thoughts on all of that.
Yeah, it's a pretty
Mouthful.
Big topic, but I think when I look at what we're seeing going on over in the war in Ukraine, it's pretty amazing what's been happening with these low-cost quadcopters. Really, I mean, it started off with DJI. Mavic platforms being used for forward deployed sort of observer positions to help guide in artillery. But now we're seeing low-cost drones being used themselves as weapon systems. And it's the technology is out there. It's easy to use and it's accessible to anybody to sort of play around with and try out. So I think what we're seeing over there is sort of what things are going to look like moving forward. And I think if it works in the air, it will also work on the ocean. There's one of the reasons we got into the maritime space instead of the airspace is there's certain parts of it that are harder and certain parts that are easier. One of the parts that's easier is if you mess something up in a drone, it crashes and breaks. If you mess something up on a boat, it may stop, but it doesn't sink. So that was one of the big design decisions that we made early on in this space. So it reduces sort of the downside of making a mistake. The only issue with that is it's logistically much more challenging because you need to be physically at the water in order to do development and testing and things like that. Whereas with a drone, you just sort of pop it up. So sort of went on a tangent there, but sense. I think that's it's been really interesting watching how maker communities are really changing what that war looks like, from all the way from sort of drone tech being applied to contraptions to do recon to actually dropping munitions and things like that. So.
And let's not marginalize just how difficult it is to make things float, too. I know that you and the team spend a lot of time thinking about how will this thing that you're putting on the water survive, whether it's moored, whether it's floating. Is it going to withstand all the weather that it needs to? Is it going to withstand the barnacles that are likely going to form at the bottom of this thing? So certainly not as catastrophic, I suppose, as something falling out of the sky. But you and the team spend a lot of time when it comes to design philosophy around thinking about how to make things float, which is no easy task, in my opinion.
Yeah, humanity's been making things float for a long time, but it is not that easy to make things float for a long time. So I have a lot of respect for people who can do that well. We had a couple of things that sank, were eventually recovered by fishermen and things like that. And it is not an easy thing to do reliably, to make things float, to make them stable. And that's really not IQT Labs is bread and butter. Like, we're not trying to be a buoy manufacturer or a boat manufacturer. We're trying to explore the design space. We have to make things float sort of out of necessity. We've been really focusing our design principles around things that already float and bolting our technology onto them. So if there's a navigation buoy that's already floating, we can put some sort of data collector. That's sort of how we've been approaching the problem, because I think that's we try to do things fast. We try to do things in a low-risk way from a deployed perspective. So that's sort of how we think about it. But not all makers have that flexibility, because we have sort of points of contact that we can work with. So a lot of them are having to go through the slog of figuring out how to do this reliably, repeatably. There's a guy named Wayne who runs the MakerBuoy project, and he's been working on this for quite some time, but he has sort of an open source buoy platform that he provides, and you can go and you can buy them from him pre-assembled and things like that. But he has a fully self-contained, solar-powered, long-duration buoy that some of them have been in the ocean floating around collecting data for 3+ years.
That's incredible.
So he's done a lot of work to sort of make that effective and work, and it's a pretty robust platform. So there's some he's got a great Instagram page. It's got pictures from his buoys off the coast of Greenland and down in Antarctica. So it's pretty impressive to see what an individual can actually do in this space if they're motivated to do so.
At the risk of a very bad pun analogy, one might suggest that the MakerBuoy project allows all ships or all buoys to rise, perhaps.
Yes,
and it had to be done.
Yeah,
puns are a thing in this series.
Yeah.
For a review of the 7 most well-executed puns, I highly recommend our listeners go to the first in this 3 series of the Maritime podcasts.
Yeah, we'll try to be competitive here, but no guarantees.
So let's shift our attention a little bit to specific areas of technology that are of interest or intrigue to you and to us at the labs in the maritime domain. You and I sort of had a planning discussion. We talked about ROVs. We talked about routing and mapping projects. What are some of the more notable projects that you've encountered in our work, especially as related to sort of national security efforts?
Yeah, I think exploration from a physical device going and exploring an area is one of the biggest areas where I think there's people who are already doing that in the open source and maker communities. There's sort of a couple of YouTubers that have sort of made a little cottage industry around building demonstrators of how to do this. There's a YouTube channel called RC Test Flight, who just built some really incredible boats/contraptions that he'll send off on 20, 30-mile missions to just go around and just loiter, do things. And right now his platforms just sort of drive around and sometimes tow him on a raft, things like that. But these are the kind of things that are doable by people if they're so inclined. So I think that's really the big piece of this is, again, just back to that autopilot system being so easy to use and so cheap. And then, again, just moving forward, I think for the maritime domain in the open source area, there's a project called OpenROV, which is really working. They sort of a company that I can't remember if they merged or acquired, but it was called Blue Robotics. They were building a lot of thrusters for OpenROV projects. And so I think that's one of the limiting areas in this space is long duration, just propulsion. A lot of that microtransat competition is really focused on sail. So you're seeing a lot of activity in sort of autonomous sailboats. I think solar electric is going to be increasingly interesting because you can get sort of a large form factor boat floating in the ocean with a solar panel on it. And as long as you have reliable electric propulsion, that gives you a pretty interesting platform. And you're no longer reliant on wind. You're no longer you can sort of go wherever you want to go and station keep wherever you want to station keep. So I think for me personally, that's an area that I think is really interesting moving forward.
That's great. I think I recall seeing on the lab floor a number of the thrusters you just mentioned, the Blue Robotics thrusters. Those things are really neat.
Yeah, we had done a just sort of an exploration a couple months ago about how easy is it to build an unmanned surface vessel. And we followed sort of a script from, there was a Japanese university that had pulled together a USV based on a boogie board. And so we took sort of our own interpretation of that, following sort of some of the work that they had done and some of their fact findings. What we found is it's actually pretty easy and pretty cheap to build something like this. I think the full bill of materials was less than $500. It's based on, again, back to that, it's hard to make things float. It's based on a platform that already intrinsically floats, the boogie board, and then just strapping things onto it. Now, that's not going to survive in the ocean, but it would do pretty well in a small lake, do okay in a river, those kind of things.
Yeah, it's not bad for the price, and certainly has quite a bit of capability attached to it. Let's talk a little bit about the AI Sonobuoy. This is a project that we have worked on in the labs for quite some time, and at a very high level is a platform that we've engineered to operate out in the open in the ocean using a hydrophone to sort of listen to and classify things that are heard under the water. Let's talk a little bit about why we chase this project, why is it that some of the decisions you made along the way were pivotal in the way that the project has unfolded here a couple years out now.
Yeah, this has sort of been a longer duration project than we typically do, but it was our first time really getting into the maritime space. It was the first project that we greenlit in this way. We really focused this project on showing where AI could be helpful in acoustic sensing systems. So a lot of times people are using acoustic sensors for everything from resource conservation to detecting. There was somebody who was using hydrophones to detect where sturgeon are for fishing purposes. And then, of course, the Navy uses hydrophones for all sorts of purposes. So we were really looking at how do you put AI on top of that in a useful way? And can you get away with a very lightweight AI model to do something as basic as detection of propeller noise or something like that? So that was really the guiding vision of the project is what do you need to do in order to build something that can fit in a microprocessor form factor connected to a hydrophone to listen for something interesting. Turned into a big can of worms that we had to sort of figure out how to solve. It's not just making things float. It's also all the upstream from an AI perspective. So AI algorithms are only as good as the labeled data set that they're trained upon. The labeled data set is only as good as the variety of data that you've collected and the quality of the labels that you apply to it. So we had to sort of reverse back all the way to the beginning and build data set collectors. We had to find places to deploy those data set collectors. We had to figure out ways to label data that we didn't really have a lot of experience in doing. Like computer vision, it's very easy for a human to say that's a dog, that's a cat. It's very hard to say that's a cruise ship on a spectrogram, which is sort of frequency versus time versus energy in the water.
So if you're a human being listening to the actual recording, as we've done when we've been out on field tests, you've walked up to him with your little recorder and said, "Hey, Vishal, listen to this. What do you think this is?" No idea.
Yeah.
I have no idea what I'm listening to in the water. It all sounds the same to me.
Yeah, that's it's actually a huge challenge. We were trying to solve it by time correlating the acoustic sounds with AIS broadcasts. That's the collision avoidance system for ships, sort of AIS. They broadcast their position. So we were hoping that we could correlate the position of the ship with the sound that we were hearing and then say that is this type of ship.
Right.
That works pretty well. There's some areas where some of the data coming off of AIS is not as useful, which is one of the things that we sort of painfully discovered over time.
Right.
But probably our biggest finding from that is that when you're in the maritime space, a lot changes over time with your hydrophone, your environment, your recordings. And depending on what maritime environment you're in, we were in a harbor, there can be a lot of not useful noise. Like ports have not just ships, but also construction projects. They have jackhammers replacing docks. They have pilings getting pile drive down to build moorings. There's a lot of spurious noise in that environment. So this sort of, if we collect data in a harbor, is it actually useful if you wanted to do a detection out in the ocean? The answer is probably no, but you need to build out a larger data set to be able to do that.
Right. So, the cacophony of sounds available in both of those environments would be largely different, I'd imagine. And I think you've proven that to be the case.
Yeah, and if you don't have somebody who's an underwater acoustic expert on the team, it's really hard to know what is useful data and what is not useful data. So we learned a lot about it over time, but it is a challenging environment. There are some techniques you can use to sort of automate some of that process, but the models are only as good as the data that underlies it. So we're still working in this space. Sort of the biggest conclusion is you need to collect a lot of data from a variety of different places, and that data set diversity is the most important thing. And also, that's an area where there's just not a lot of data out in the world. Like, there's been a lot of work in computer vision to open source data sets, to open source machine learning models that are already pre-trained. That doesn't really exist in underwater acoustics for a variety of reasons, but that's one area that really slows down innovation, and it's also why we had to collect our own data.
Yep. I want to do a quick shout out. You made mention of AIS data sometimes not being the most trustworthy source of, say ground truth. A colleague of ours, Ari Chadha, wrote a really great post about this. Our listeners can check it out at IQT.org. And I also want to make mention of we're sort of transitioning into discussing some of the things that slow down development or are challenges within the open source and maker community space when it comes to maritime. And you've already addressed sort of the availability of good quality data, especially in the concept of training and using algorithms to do things like classification tasks. What are some other sort of hindrances or points of friction that you see in this space that make it more difficult for people to contribute, say, at the individual or small group level in the maker community?
Yeah, I think the biggest thing that we learned is location is everything. We're based in Virginia, and there's only a couple of places that we can actually do maritime work because we're in Northern Virginia, so we're not near the ocean. We're also not really near the Chesapeake, which are sort of the two most natural places. So our ability to test here is pretty much the Potomac River and a couple of lakes in the area. What that really means is it slows down the speed at which we can iterate our development. So we like to iterate fast. We like to throw things out into the world and try them every 2 to 3 weeks or so. But logistically, getting boats, getting hydrophones, getting all the gear, driving it 150 miles to go to a place where we can actually test is logistically complicated, especially if you're trying to fit it into a normal work day. So that was probably the biggest thing that slowed us down. And then choosing where you're doing your deployments. We had a deployment down south in Florida, which was really hard for us to be able to access. And we wanted to be able to make regular updates to it. We were not in a position to be able to do that easily. So we basically ended up only doing one iteration on some of our data set collectors. So I think logistics is the part that surprised me the most of how complicated it was. And I think that would apply to the majority of people who want to get into this space if they're not right next to a very available body of water.
But Mike, we have a pro tip for individuals who might find themselves constrained or landlocked, don't we? It's the IQT Labs Aquatic Facility. As I recall, we have a 5-gallon Home Depot bucket full of water.
Yes, this is true.
That does some stuff for us.
Yes. It also needs to be, the water needs to be changed regularly, or back to sort of biofouling problems, it starts to smell a little bit.
Yes, we've encountered, again, a pain that we've learned from.
Yeah.
We've certainly learned from at the labs.
Yeah. Just on the biofouling topic, like this is another area that if you're starting to talk about long duration, this is also an important finding that we had, which there's a lot of literature about this, but lots of things grow in the water. And over time, our hydrophone got less and less useful because when we pulled it out after a couple months, it was covered in barnacles. And so from think of a hydrophone as a microphone. If your microphone right here in front of us was covered in barnacles, it probably wouldn't work very well.
Way less effective.
Yeah, so that's another piece of this that actually may be the life-limiting part on sort of a forward-deployed sensor is just when it gets covered up in barnacles, that's sort of the end of the line for its effectiveness as a detector.
I remember you sent a little video as you collected that piece of hardware from the water. It looked like it was breathing. The thing, you're holding it up, and it looked like it literally had a pulse and a respiratory rate associated with it.
There was literally a crab living in it. So
Incredible.
It was pretty incredible.
Mike, we're approaching time, but I want to make sure that we get a chance to do Mike's Callouts. Mike's Callouts is a section of the show that we invented for this very particular show,
That's
where
right.
Mike gets to call out specific makers and doers in the maritime space doing interesting things. Why don't you kick us off on the Mike's Callouts?
Yes, I already mentioned a couple of these already, but Daniel Riley of the RC Test Flight YouTube channel does a lot of really impressive work building, I think I described it as contraptions and unmanned surface vessels. Is really good at doing autopilot tuning and just sort of exploring what's possible with this technology. So it's really interesting, very technical. Peter Schriepel is also sort of in that same category, but he's got sort of an interesting track where he's retrofitting autopilots onto existing boats. So he's bought a couple of boats and then integrated ArduPilots and Pixhawk autopilots onto them.
That's so cool.
So I think that's just really interesting and a way to get sort of an autonomy on a thing that already is guaranteed to float as long as you don't do anything crazy. And then two people that we've worked with a little bit in the past. I mentioned Wayne Pavalko of the MakerBuoy. So we've worked with him a little bit. He's doing great work. He's got tons of buoys out in the water doing interesting data collection and science. So he's done a lot of work making this a sort of robust and reliable platform that can actually be used. And then Adrian Studer, who makes AIS receivers called Daisies. The AIS and Daisy is for AIS. And so he's got a great set of pretty low-cost AIS receivers that people can use as hobbyists. He's got a version that connects into autopilots to do avoidance of ships and things like that. So just a couple of groups that we sort of look at for what is possible for an individual to do, and then what are some useful tools and design principles. I think all four of those sort of apply.
That's great. So. And I'll place a shameless plug for IQT Labs and some of the work that we've done recently in the space. The AIS in AI Sonobuoy is in fact also AIS. So yes. Mad props there. Mike, I think it is almost time for us to clean out the water in our aquatic facility bucket. So with that, I turn our attention back to our listeners. And first, I'd like to say thank you for joining us for this conversation, Mike. And to our listeners, thank you for tuning in to today's episode of IQT Explains on the IQT podcast and part 2 of our 3-part deep dive. There it is. There's a pun. Series Exploring Maritime Technology. We encourage you to tune in for part 3 to learn more about the policy aspects surrounding this domain, and also plug the first part of this where we discuss the investment and commercial landscape around maritime domain technology. Please make sure to subscribe to the IQT podcast so you don't miss out on future content, and leave us a review or comment to let us know what you think or what content you'd be interested in us covering in a future podcast. Thank you all again, and everyone here in the studio, thank you all for your time and attention today. Till next time.